Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Giant Steps by Math Pesto, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, we can get a row eventually, column, and designated 9-cell region. Adjacent digits on a green line differ by 5 or more. These are usually known as whisper 5 lines. I tend to call them as they're normally known as German whisper lines. I typically call them as whisper 5 lines because a setter basically called them that, and it made a lot of sense because of how extensible that is to other types of lines. Anyways, and so I will be calling them whisper 5 lines, but just know that basically it's the same as a German whisper line. So if there was a 3 here, then these digits would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9, and that's the reason why those would have to be 8 or 9. So that's an example of how whisper 5 lines work. And we have a black dot joins 2 digits in a 1-to-2 ratio. Not all black dots are necessarily given. So for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1-to-2 ratio between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, where should we start? Okay, let's start with column 2. We have all digits are either on a German whisper 5 line or a black Kropke dot, except for 1. And 5 can never be on a whisper 5 line because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. And if you add 5 or more to 5, you get 10 or more, which are not digits. And 5 also cannot be next to a black Kropke dot because if you have 5, you get 2.5. And if you double 5, you get 10, neither of which are digits. So since all of these digits in column 2 are on black Kropke dots or on a whisper 5 line, you can only have a 5 in the cell that is not. So this is a 5 here. Which means in row 4, for similarity's sake, we have digits that are on whisper 5 lines, or cannot be 5, or are next to a black Kropke dot, which means 5 can only be in the cell which cannot have any of those, so it must be here. That means in row 5, where is the 5? It has to be here. So box 8, we have a similar thing. We have a lot of digits on the whisper 5 line, one next to a black Kropke dot, and these can't be 5 because of 5 in the column, so this must be 5 here. That means in column 4, we also had digits which were next to a black Kropke dot or on a whisper 5 line, so therefore this must be a 5. Okay. In box 1, we have a lot of digits next to on a whisper 5 line, next to a black Kropke dot, and can't be 5 because of 5 in the row, so this must be 5 here. That leaves in column 1, 5 has to be here because 5 can't be here because of 5 is in the boxes and can't be here because 5 can't be on a whisper 5 line. So that's 5. That means 5 in box 9 is here and 5 in row 3 is there. Okay. So one of the interesting things was the whisper 5 lines in column 2. Each of those is next to two unique digits on the Whisper 5 line, right? This is next to this and this. This is next to these two. And it's the same for this, and the same for here, and the same for this, and the same for this one. So 4 and 6 cannot be next to two unique digits on a Whisper 5 line. So therefore, where can the 4 and 6 be? They have to be here. So this is 4 and 6. 6 has to be in a 1 to 2 ratio with only 3. But 4 can be in a 1 to 2 ratio with 2 or 8. So we're guaranteed one of these has to be 3. And the other one can be 2 or 8. We're not sure which. That's what we have there. So I think for every column 2, 5, and, well, 8 doesn't have as many steps. 5, you have a similar situation, right? You have 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. Because of what is limited. So 4 and 6 have to be in the remaining cells, which are not next to two unique digits on a Whisper 5 line, which would be all of the cells that are on a Whisper 5 line. Therefore, this must be 1, 2, 3, and 8. If this is 3 here, this is 6. If this is 8, this is 4. If this is 1, if this is 2, this could be 1 or 4. If this is 2, if this is 1, this has to be 2. Okay. 5 also has a similar situation. Every digit that's on a Whisper 5 line is next to two unique digits on a Whisper 5 line. So therefore, this must be 4 and 6, and this must be 4 and 6. We don't have that case, though, in column 8, 1, 3, etc., etc., right? Let's mark what these are. So what I like sometimes doing on Whisper 5 lines is just setting a random color and then setting the opposite color for the adjacent cells. Because we know low digits always have to be next to high digits and vice versa on a Whisper 5 line. The low digits being 1 through 4 and the high digits being 6 through 9. And the reason why you know that is, say you take 1 through 4, what digits can be next to it? Well, 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can be next to 9. And those are all high digits, right? So that's why, and it works the other way around. So these have to be essentially low, one set with the other set being the one next to it. So these are all green, and these are all pink. Okay. We can choose other sets here. So I'll choose dark and medium here. So then these are all dark. And these are all medium. What else do we know? One of these is 3. So it would have to be next to an 8 and a 9. But we don't know which is which. Hmm. Oh. Hmm. Well, that's not true. This can't be 4 or 6, so we know it's 1, 2, 3, 7, 8, 9 there. Um, 'Let's try yellow and orange here. So these would be yellow. We'd have orange here. We know 4, 6 as a pair. These have to be 1 low, 1 high, 1 low, 1 high. So this must be orange over here with the 5. This is 1 low, 1 high, 1 low, 1 high, 1 low, 1 high, but we don't know what color this is. Three and six would be one low and one high, but two and four could be the same set of low and high. Hmm. Hmm. This is in a 1 to 2 ratio with this. So we have 1, 2, 3, 4, 6, 8. Um, what about these? Hmm. So these we know are 1, 2, 3, 7, 8, 9. Again, these are 1, 2, 3, 7, 8, 9. No 3 here, no 3 here. 1, 2, 7, 8, 9. 1, 2, 3, 7, 8, 9 here. 1, 2, 3, 7, 8, 9 here. 1, 2, 3, 7, 8, 9 here. This is obviously 1, 2, 3, 7, 8, 9. So is this. So are these 3. So are these 3. Ah, we have a 4, 6 pair also in row 2. So this is 4, 6. This is 4, 6. Huh. What do we mark these? Um, hmm. Let's remove the coloring here first. And let's use orange and yellow. So yellow, orange, let's mix this yellow, which makes this orange. Oh, well, no. We don't know what color that is. That's the problem. So yellow 4, 6 has to be one of these two, right? Orange 4, 6 is one of these two. This is orange 4, 6, so this is yellow 4, 6, which makes this orange 4, 6. This is orange 4, 6, so this is yellow 4, 6. Orange 4, 6 is here, which means this cannot be orange 4, 6. This can't be orange 4, 6 because it's next to two unique digits. So this must be orange 4, 6 here. That means this, we already knew this was orange 4, 6 here. Okay, no orange 4, 6 here or here. No orange 4, 6 here or here. Yellow 4, 6. Can be either of these. Hmm. Hmm. These are 1, 2, 3, 7, 8, 9. These are 1, 2, 3, 7, 8, 9. Oh, this must be 1, 2, 3, 7, 8, 9 because we have both 4 6s in that box. Hmm. This cannot be 4 and 6 because they see the yellow 4, 6 and the orange 4, 6. So it's 1, 2, 3, 7, 8, 9. Okay, so say this was a 4 here. If this is 4, this would have to be 6 and 3, and this would be 9. So that actually does work. What happens if this is 6? If this is 6, this is 1. This must be 4 and 8 then. So they both work. Yellow 4, 6 must be either here or here. In column 4. Okay, so the greens must be the same as the medium grays. Because we have 3 darks here. These are opposite sets. And we have 2 medium grays. So therefore, this must be part of the medium grays. So the medium grays are green. And the dark grays are pink. Okay, that should be helpful. Same with these. These 3 have to be pink, because if they're green, we'd have 4 greens, but that doesn't include the 4, 6 pair. So these are pink, which makes this green. Okay. Which means pink. Pink and pink are the same set when they are in a 1 to 2 ratio with 4 and 6. 6 is always going to be with 3, so since these are the same set, it must be 2, 3 as a pair. That eliminates 2 and 3 in the rest of the column. So this cannot be 2. This can't be 2. This can't be 2. We know... this can't be 2. This can't be 2. We know pinks are low. So pinks... Oops. No, that's not good. Pinks are low. That means greens are high. So this cannot be 1. This has to be the 1 here as the only... So this cannot be 1. This can't be 1. No 1. No 1, 2, 3. No 1, 2, 3. So it's 7, 8, 9. This can't be 1, 6, or 8. This can't be 7, 8, 9, or 1. No 7, 8, 9. No 7, 8, 9. No 7, 8, 9. No 1, 2, 3. No 1, 2, 3. No 1, 2, 3. These cannot be 7, 8, or 9. Okay. Two, 3, and 4 are here. If this is 3, obviously this is 6. If this is 2, it's 1 or 4. If this is 4, this is 2 or 8. So that's still pretty broad. So this is low. So this could be 1, 2, 3, or 4. We don't have anything here. So this is 1, 2, or 3 also. This 1 eliminates 1 from being here. So that's 2 and 3. Also no 1 here. So this is low, which means this is 5 and high. So this is 5, 7, 8, 9. Which means we cannot have 7, 8, 9 or 5 in the rest of this box. So this is 1, 2, 3, 4, and this is 1, 2, 3, 4, or 6. We kind of already knew that, though. Anyways, well, kind of good to know. So this is red or pink. This is 1, 2, 3, or 4. This has to be 1, 2, 3, 7, 8, or 9. So is this. Same here. This is 1, 2, 3, 7, 8, 9. Okay. This is 2, 3, 4, or 6. Don't know which. This has to be yellow, whichever it is. We don't know what that is, but this has to be a yellow. Because we have 3 reds, and 3 blues in the column. And this is orange, so this must be yellow. But it does not have to be the yellow for 6. It could be low still, right? This is 1 through 4 here. 1 through 4 here. This is 1, 2 of each set. So this has to be orange, right? This is yellow. Therefore, we have a low, high, and low, high here. So this must be the orange. We have 1 orange here and 1 red here. that guarantees that in box 5, the remaining cell has to be red. So that leaves these as blue again. So these are blue and these must be red. But this could be 6 through 9 here. So no 2, 3 here, no 1, 2, 3 here, no 7, 8, and 9 here. This is 1 through 4 again, 1 through 4, 1 through 4, no. This has to be high, so this is 8. 8 is in a 1 to 2 ratio with 4. So this is low here. And this cannot be 4. This cannot be 4. This is 1, 2, 3, 1, 2, 3, 1, 2, 3. No 8 because of 8 in the box. So this is 4, which means this can't be 4. This can't be 4. We have 4 low digits in column 4, which means orange has to be red. And yellows are low. So this is 4 here. This is then 6 and 3, which is next to 8 and 9 on a Whisper 5 line. So no 3 here, no 3 here. This is 2, 3, 4. This is 2, 3, 4. One of these is 4, so this cannot be 4 here. This is the low 4 here. Low 4, low 4. That means this is high 6, high 6, high 6, and high 6. This has to be 6 or 8 here. No 8 here because of 6 and 8 in the column. No 8 here. This can't be 4. This can't be 4. The remaining digits are high in box 6, and this can't be 6 because of 6 in the column, so this must be 6 here. That means this is 7, 8, or 9. No 6 here. 6, 7, 8, 9. This is 3, which eliminates 3 here. This has to be 7 and 1, 2, or 4 here. So this cannot be 7, no 7 there. This is not 3, so this is 2, which means this can't be 2. No 2 here or here. This is 6 or 8, which is in a 1 to 2 ratio with 3 or 4. So 3 or 4 can only be next to 8 and 9. So this is 8 and 9, 8 and 9, which means this cannot be 8 or 9. It's 7. So 7 is in a 1, can only be next to 2 out of 2 or 3 on a Whisper 5 line. So this is 2. No 7 here, no 7 here, no 7 here. So we have an 8, 9 pair in box 1, which eliminates 8 and 9 in the rest of the box. This can't be 8 or 9. It's 7, which forces this to be 9, which forces this to be 7. That makes this can't be 7 or 9. It's 8. So no 9s here. No 8 here, no 8 here, no 8 here, no 8 here. This can't be 7 anymore. We have an 8, 9 pair in box 5, which eliminates 8 and 9 in the rest of the box. This can't be 8 or 9. It's 6, which makes this 3 to be in a 1 to 2 ratio. This can't be 2 or 3. It's 4. So this can't be 4 or 2. It's 1, which means this can't be 1 here. This is 3, which makes this not 3. That's 1. 1 eliminates 1 here, so that's 2. No 1 or 2 here, so this becomes a 4, 7 pair. 2 eliminates 2 from being here. 8 eliminates 8 from being here, so this is 9 and 8. 9 eliminates 9 here, so that's 8. 8 eliminates 8 here, so that's 9, which makes this 8. Which means this can't be 8, that's 7. 7 can only be next to 2 and 1 on a Whisper 5 line, so this must be 2, which makes that a 1. 2 eliminates 2 here, so that's 1 and 3, which eliminates 3 here, so that's 1. 2 eliminates 2 here, so that's 3, which means this can't be 7, that's 9, which makes that 8. Which means that can't be 8, that's 9, which means this can't be 9, that's 8. This can't be 1 or 2, it's 3. This can't be 2 or 3, it's 1. And this can't be 1 or 3, it's 2. No 1 or 3 here, so that's 2. No 2 or 3 here, that's 1, which means this is 2 here. No 1 or 3 here, that's 2. And 1 eliminates 1 here, so it's 3. 9 here eliminates 9 here, so it's 7, which makes this 8, which makes this, and the 9 in the row eliminates 9 here, so it's 7, which means this cannot be 7. This can't be 6 or 1 or 2. No 1 or 2 here. 4 cannot be next to 8 on a Whisper 5 line, so this is 3, which makes that 4. That's 3 in the corner. We celebrate because we know we're close to solving it. This 8 and 9 eliminates 8 and 9 here, so it's 7. 8 eliminates 8 here, so it's 9. 7 eliminates 7 here, so it's 4 and 7. So this is low and this is high. And we should have a lot of digits. So we have 8 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. We know where the last one has to be. It has to be there. Do we have 8 twos? We do. 1, 2, 3, 4, 5, 6, 7, 8. So we know where the last 2 has to be. It has to be here. 3. We have 8 threes. We know where the last 3 has to be. It has to be there. 4s. We have 8 4s. We know where the last 4 has to be. It has to be there. 5s. We know now 5 cannot be here anymore in row 8, so it has to be here, which makes this 9, which makes that 5. So not pink, and this is not red. So that's all the 5s. 6s. We have 7 6s, but in column 6, 6 can't be here because of 6 in the row, and the rest is filled out. So this must be 6 here. And therefore we have 8 6s. We know where the last 6 has to be. It has to be there. We have 8 7s. That leaves this as a 7. We have 8 8s, which leaves this as an 8. And then the 9s have to be the remaining digits. And that's a solution. Interesting. It wasn't as straightforward as I thought it would be. Mainly because you have to be careful about making too many assumptions, right? But eventually we got there, so that the steps were all the same with what set they could be, right? Blue, red, blue, red, blue, red for all the sets. But we couldn't guarantee that that was actually the case until we went through all the possibilities. So that was actually fairly interesting. Particularly this part, right? I like this, actually, this logic here, because this was yellow. This had to be orange, which made that yellow, which made that orange. And since we had a yellow here, this had to be high. So that was pretty cool. Anyways, I hope you thought this was cool and enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.